Hi, everyone. Thanks so much for joining today. We have Mark Gamble back to talk about everything mobile and IoT. I want to encourage you to check out the docs section for more information, including two upcoming webcasts. This webcast is number one of a series of three that Mark has put together for you. November 19th and 20th, we're going to dig a little bit deeper with a session called Master AI at the Edge with mobile sync, search, and security. So a little more on the technical side, a few more demos. And then in December 10th and 11th, we are going to go into the code. So that one is specifically for developers looking to learn more. We're going to go behind the scenes of an AI powered mobile and IoT app. So please check out those other two sessions. Would love to see you again. We do invite you to add your questions to the Q&A today. And, chat with us. Let us know where you're from, how you're doing today. Would be great to learn more about you and about what you're trying to get out of the session today. And with that, I will kick it over to the famous Mark Gamble, Director of Product and Solutions Marketing, here to talk about everything mobile and IoT happening at Couchbase. Thanks a lot for being here, Mark.
Thanks, Suzanne. Great to be here. I hope to be famous someday, so I appreciate that cool intro, and we'll see. But I'm here to talk about the famous Couchbase Mobile, and I'm especially excited to be here. Talk about mobile apps, and specifically how developers can ensure the apps that they build will provide an always-on and always-fast experience, no matter where your users may go. I'll be going through some of the challenges in achieving that with mobile apps today, and of course cover off on how Couchbase Mobile enables a mobile app ecosystem that provides guaranteed uptime and real-time speed through a comprehensive mobile database platform. So I'm also going to be showing a live demo today, so be sure to stick around for the whole program. And with that, let's go ahead and dive right in. All right, so to set the stage, this slide sort of encapsulates the end goal for our customers. They want to produce apps that adapt themselves for individual users because that's what keeps people using them. And ultimately, by adaptive, we mean apps that are hyper-personal, that feel like interacting with a friend or trusted advisor. And they're always in context. They always present relevant options. They're driven by trustworthy data for accuracy, and they operate in real time and work everywhere, right? This is kind of the penultimate goal for a lot of our customers. And by working anywhere and everywhere, I mean with or without internet. And this final point, the ability for apps to work anywhere and everywhere, is a central theme of today's talk. The goal is really simple, right? You want your apps to always work all the time, but achieving it comes with significant challenges that can be really hard to overcome unless you have the right database. So let's go to the next slide. A little bit about mobile apps in general to sort of set the stage. Mobile app usage is increasing worldwide, not only in user volume, but in daily time spent on applications. TechCrunch recently reported that mobile users now spend between 4 and 5 hours on smartphone apps every day, daily. That's roughly a third of waking hours. Amazing. But when you take stock of or when I take stock of my own usage of my phone, it starts to become very realistic. I do spend a lot of time on my phone. And when it comes to which apps users use, there's no shortage of choices, right? Google Play offers around almost 3 million apps and games, and the Apple App Store has about 4.5 million games and apps. But this huge volume of apps and the increasing length of time that users will spend on them, hardly guarantees that any given app will be successful. In fact, it's really quite the opposite. Nearly 1 in every 2 apps are uninstalled within 30 days after installation. And losing 80% of mobile users is actually considered normal for all but the most popular of mobile apps. And a big reason for this high rate of app abandonment is poor user experience. particularly slowness and unreliability. 70% of mobile app users will abandon an app that takes too long to load. And 84% of app users will abandon an app if it fails just 2 times. And these facts really emphasize that the margin of error is small when it comes to keeping users happy and engaged in these applications. So, providing that fast, reliable experience is vital for the success of your mobile apps. So again, using the right database, one that's built for mobile apps, is really key to achieving this. And it should be no surprise to any mobile app developers out there. Your users don't just expect apps to be innovative and personalized and responsive, of course, all that, but they also sometimes expect magic, right? They want apps to defy physics and work at lightning speed all the time, no matter where they go. They expect an always fast, always on experience, so they're just abandoned without hesitation. And to make matters worse, they're constantly moving around in and out of network coverage, and that makes expectations even more difficult to meet. So how can an app deliver these, an always fast, always on experience for their users under these types of conditions? So the problems that Couchbase Mobile solves can largely be rolled up into these 4 core points. First, speed. Our customers need to provide that experience that meets the demands of their users who expect their apps to respond immediately with the information that they are asking for. And absolutely, I'm one of those, right? And then there's reliability. Those apps need to be impervious to inherent internet slowness and outages. And for security, apps that handle sensitive information have to adhere to strict requirements for regulatory requirements and regulatory compliance, that is. And then lastly, bandwidth usage. Network usage can really be a choke point for applications. And shared capacity introduces unpredictable bottlenecks, and egress charges for data from the cloud can tend to get really, really expensive. So these represent sort of those top challenges where our customers will face in a nutshell, but they also represent the key benefits that customers get from Couchbase Mobile. So to explain kind of in more detail how these challenges can really impact the user experience, let's take a look at an actual customer who came to us with some tough challenges. So Emirates Airlines, they have built their brand around a premium experience for passengers. And, we've sort of, what did they want to fix? Well, to set the stage, we've all been there, right? You're sitting on the ground on a flight, and a technician comes on board with a clipboard, a pen, and paper. And, this is how most airlines will consolidate their pre-flight checklist and get approvals for departures. Very manual. But as you're watching this, down the aisle, you're wondering, where am I going to make my connection? We have a very tight time frame. Will we be taking off on time? So Emirates wanted to digitize their paper-based pre-flight check process to alleviate these types of concerns for passengers and use tablets instead to make it easier and faster for pilots and crew to record inspections, prep the cabin for the next flight, these kinds of things. And the app is intended to contribute to on-time departure, improving that dramatically, and more importantly, also contribute to safety. Digitizing meant a faster, more accurate process. But there was a problem. The first iteration of their application, these tablets would lose internet during inspections on the tarmac and essentially become unusable without a connection. And Emirates knew pilots wouldn't use the app unless it was 100% available. They'd go back to paper before struggling through this unreliable experience. So in short, Emirates needed a way to eliminate those dependencies on a central cloud data center, while at the same time ensure that the entire crew can share data, right? So why is it that relying solely on a cloud-based data center and the internet can present these problems? And it's because of that connection. The internet becomes a problem. And let's illustrate that with a few diagrams here. And the cloud-only model for applications is great, where there is consistent, reliable connectivity. But when you're talking mobile apps, this can become, of course, a challenge. So here we see an array of typical devices across the bottom of our diagram. The usual suspects: mobile phones, laptops, IoT devices, etc. And they're accessing data from distant cloud data centers via the internet with all of its hops and inherent unreliability. If that connection slows, so do the apps, and users will get frustrated. And you can see where this is going. If the connection goes down, apps will grind to a halt, and that results in costly business downtime. And then for specific use cases, such as those in healthcare or government or defense, these are areas where data privacy requirements can actually prohibit storing and processing data in the cloud. And all of these limitations present barriers to meeting the requirements of a modern mobile application. So, these types of requirements represent a growing class of applications that require 100% uptime and real-time speed guaranteed, regardless of internet connectivity. And edge computing is the answer. So the goal of edge computing is to bring data and compute closer to the applications and users that consume it and produce it. And to do so, you need to do things like embed a database to edge clients, reducing dependencies on the internet. And you need to sync data from the cloud to the edge and back for consistency and integrity. So this model will speed up apps because it makes them essentially, faster, more reliable. It's bringing data closer to the users. That local data processing removes internet slowness and outages from the equation. And it also handles privacy better because sensitive data never has to leave the edge. And it promises more efficient bandwidth usage by lessening the load between the cloud and the edge. And that's really important when on shared networks where bandwidth can vary depending on time and demand, right? So you can see how we're solving those four main problems with edge computing. But we haven't gotten to the Couchbase piece yet. Just in general, edge computing. So edge computing is a distributed framework. It's a distributed computing framework that leverages co-located servers as well as edge devices for data processing. And from our standpoint as a database, it's really important to note the spectrum of data processing at the edge. That is where the data happens, to coin a term. So on one side, there's this concept of a standalone smart device, and this is where the data is embedded on the application, and it's in the app that runs directly on the client that uses it. And again, those are your smartphones, tablets, IoT devices, even desktop applications can count. And then on the other end, you have edge data centers in the form of maybe an IT closet in a store, or a rack on a cruise ship, or an edge data center, in a metropolitan city. So where a specific application is deployed within this spectrum really depends on the scale and number of downstream clients that it serves. But across this spectrum, regardless of the deployment model, in every deployment, the data is brought closer to the application or clients that use it. So another diagram. This one's a little more detailed here, but meant to illustrate the edge computing architecture and topology. So here we will illustrate how edge computing addresses those issues of speed and reliability by moving data storage and processing closer to those clients that use it. So here, notice in the middle, between the cloud and the edge devices, we've introduced an intermediate tier of data processing edge nodes. And again, that could be on-prem, such as in a rack on a big box store, for example, or on a cruise ship, for example. On-prem type of models would be the edge, and including, where appropriate, even to the devices themselves here at the bottom. And again, this makes applications faster and more resilient by eliminating those dependencies on a distant cloud data center. And it makes them more secure by isolating data close to the edge. No sensitive data ever has to leave the edge in this architecture. And edge computing architectures also make apps more reliable. If the central data center becomes unavailable for any reason, apps that use edge data centers will continue to operate without interruption. And if the cloud and edge data centers become unavailable, edge devices with embedded data storage service their own data center and continue to operate without interruption until that connectivity is restored. And with this combination of built-in synchronization and the ability to run as a self-contained partition in any part of this architecture, including on device, edge computing provides, again, the highest guarantees of uptime, availability, and speed for applications. So finally, now we'll overlay our Couchbase logo to this architecture. So I spent so much time explaining the benefits of the edge architecture because Couchbase Mobile fits it like a glove, because we can run and sync data anywhere, in the cloud, at the edge, on-prem, within a 5G network, leveraging some of these new edge services from major CSPs, and even directly on edge devices, and seamlessly sync data between and within the layers, including between devices via peer-to-peer. So we don't even have to rely on an internet connection when we're at the very, very edge. We can synchronize between devices using local networks. I'll show you how that works in our demonstration in just a bit. So this fundamental capability allows us to support any complex edge architecture to meet any speed, availability, or security requirement for our customers. So now let's circle back to the Emirates use case that we started off with. And Couchbase, through this unique edge support, was able to deliver on all of their requirements. By embedding the database to their tablets, the app works 100% of the time. Their pilots and crew trust it and rely on it every day. And the data that's collected is synced via peer-to-peer to all the other tablets in near vicinity, so the entire crew has the same information in real time. And additionally, the data is synced to ground systems as connectivity is available for the internet. So that information's then synchronized up to the cloud and down to the next airport for ground crews to receive that plane and continue it on its journey. So in short, Emirates adopted Couchbase Mobile and the mobile database platform for their e-TechLog application. And it helps them maintain one of the best on-time and safety records in the industry. So now let's get into the specifics of our mobile support. Our mobile capabilities are a specialty, but really they're just part of the broader enterprise capabilities of Couchbase. So that's really where the story starts. And Couchbase is a cloud-native NoSQL database that's used to power gigantic applications like, LinkedIn, PepsiCo, Tesco, Comcast, Amadeus, big household names who use us to power their critical applications, mobile and otherwise. And that's because Couchbase is so versatile and powerful. So it's a combination of database capabilities, which is why we call it multi-purpose. First, it's an in-memory KV store for hyper-fast responsiveness, combined with this notion of a distributed JSON document-based data storage for scale, resilience, and development flexibility. And to this, we add support for vector search, full text search, eventing, columnar analytics, containerization, and mobile sync, right? These are all data access patterns that customers no longer have to bolt together from a bunch of different technologies. They get it all from one single platform. And Couchbase supports relational constructs such as SQL queries and ACID transactions. And these are things that are not typically found with document databases, but they're part and parcel with Couchbase. So developers can use their existing SQL skills and adopt it more quickly. And customers can deploy and use Capella. This is our database as a service. It's fully managed and hosted. Or you can install and manage your own Couchbase deployments in the cloud or on-premise. And this represents Couchbase in a nutshell. So how do we support the edge architecture? And this is, of course, with Couchbase Mobile. So the Couchbase Mobile product stack is made up of three foundation components. Couchbase Server is our flagship distributed NoSQL document database I just talked about. And then there's Couchbase Lite, and this is the embeddable version of Couchbase for mobile and custom embedded devices. And this also supports SQL and vector search and full text search. So it's a lightweight version, but truly brings all of the power of Couchbase right on the device itself. And then for synchronization, Sync Gateway sits in between, and it's responsible for secure data sync, routing, and access control between mobile clients and server tiers. And these capabilities can be deployed two ways: fully managed, again, with Couchbase Capella, or self-managed, where customers can install Couchbase themselves on public or private clouds, on a cloud edge service, or on-premise. So some common topologies, we'll just dig into this for a moment. Capella is available on AWS, GCP, and Azure, and it provides the hosted and managed database as a service, which runs Couchbase Server under the hood. It also provides fully hosted and managed app services, which runs Sync Gateway under the hood. So common topologies for app services applications include here at the top, offline first sync. And this is where apps work in isolation for extended periods of time using Couchbase Lite for embedded data processing. And when connectivity is available, they use app services for secure data sync over a WebSockets-based protocol. Another common topology is peer-to-peer with Cloud Sync. And this is where Couchbase Lite is deployed on the edge devices, and to facilitate the collaboration, the peer-to-peer sync feature of Couchbase Lite is used to sync data between those edge devices, even when they're disconnected from the internet. And when there is internet, clients can sync upstream to the Capella database as a service, leveraging app services. And lastly, app services can support mobile and web apps with secure access to Capella via REST calls. And in this topology, clients can either embed Couchbase Lite or call the REST API directly from the web or desktop applications. So Couchbase Lite provides native support for iOS, Android, and Windows platforms. Desktop and web server apps can be built with .NET and Java. And the C API support that we have allows developers to build applications in C that run on nearly any embedded platform. We also recently announced support for React Native through a community project. So Couchbase Lite allows our customers' development teams to develop and deploy mobile applications quickly because of that JSON flexibility, simple to use APIs for database CRUD operations, and SQL query support, as well as vector search on device. All right, now let's get to the fun part. And I'm going to start with a demonstration. I'll stop sharing slides, and we'll start sharing my screen. And all right, we should be sharing now. And all right, we'll put the presentation on pause for a moment. All right, so I'm now sharing our sample application. And I'll show you where you can actually get this. This is an application called Simple Data Sync. And it's available on the App Store. We'll bring up a QR code in just a moment, and I'll show you the architecture behind it. But to start off with, this is a simple application, but it's a working example of Couchbase mobile synchronization in action. So when you download the app, it installs with Couchbase Lite under the hood, and this allows it to run even without internet, as well as sync data with other local devices running the app. So first, the application displays a color. And we're looking at my mirrored iPhone. I'm just mirrored on screen right now. And when you tap the color, it will change color. Okay, very simple. Next, I'm going to bring up the application running locally. This is a second device. In this case, it is the application running on my MacBook. And these are two separate devices. Now, when I tap my iPhone screen, let's actually relaunch it. Looks like it might have fell asleep here. There we go. Now notice when I tap it, we're synchronizing between the two devices. So each color is a data value that's stored in the Couchbase Lite database, and the sync feature keeps that data consistent at all times across other devices running the application. So peer-to-peer sync allows users with the app in close proximity to one another sync between those devices without going through the internet. Just using local networks in this particular case. And it's great for collaboration and isolation, as I mentioned earlier, where the internet might be unavailable, but users still need to synchronize data between devices, such as think mobile clinics, or maybe emergency crews in a disaster area, or airliners, that where the crew's on the tarmac and unable to leverage internet. So next, let's take a look at cloud to edge sync, where users may be separated by great distances. So on my phone, I'll show you a setting here. Capella App Services is how apps can sync across the globe, maintaining that consistency even when users are across the country. So I've configured an app endpoint in App Services on Capella for the color feature to do just that. And so here on my phone, we see those settings for App Services, and I simply add my username, password, and endpoint URL. And when enabled, I'll sync with anyone else connected to the endpoint. So in fact, let's bring out my colleague, Matt, to show this off. So Matt's across the state. Yeah, hey, Matt. So you're across the state from me right now, but why don't you go ahead and hold up your phone and give it a tap. You're also connected to App Services. There we are. We're synchronizing. Okay. So not unexpected. We're synchronizing now through that cloud control point. But notice that, of course, my phone is connected to App Services, so it's synchronizing with Matt whenever he taps. But also notice that my second local device running the app on my MacBook is also changing it, but I haven't configured it for App Services. In fact, we can see in the settings, everything's completely blank. However, it continues to synchronize because of peer-to-peer sync from my iPhone. So we're demonstrating in very simple terms a complex topology. There's a very complex topology at play where communities of users can stay in sync even if with only one device connected to the internet. So finally, I'm going to push some data down. We'll do the final use case, and I'll bring up our browser and go straight into Capella. And we'll go ahead and looks like I need to log in. Live TV, folks. It's never goes quite as you had planned, but luckily we're dealing with Couchbase, so everything works. So I'm going to go into Capella and let's go straight into the documents section. And this is the actual data that is feeding the application. And I'm going to bring up the actual document itself. And so we'll do the profile document. And so here we see that it's color number 1. We're looking at the data that dictates that color. So I'm going to change it to color number 2 and save that document. And when we do, notice that behind the scenes, both of my devices changed. So we just did a synchronization down from the cloud to my device. The secondary device inherited that change via peer-to-peer. And Matt, I'm guessing that you probably also have inherited that particular color.
Yep.
Great. All right. So, what does this mean in business terms? Well, it demonstrates the ability to read, write, and synchronize data, both peer-to-peer as well as over vast distances. And we were even talking about this setting up for the demo. I realized only after the fact that my app service that I'd set up in Capella was previously set up when I was traveling in Asia. So that's actually using our database as a service and app services running in Singapore, but still has that lightning fast sub-millisecond response time for that synchronization. I think that's incredible performance. And the types of applications that this simple concept can actually power, you can probably already think. You can synchronize and update user profile attributes and settings, catalogs, game scores or rankings, current machine conditions on the device that it happens to be running in, current location, and more. So it has a vast number of applicability of use cases. We used a color just to make it simple, but if you can sync a color, you can sync anything. So now let's jump back over into our presentation. And I'll once again get into our slides and make sure I'm sharing the right one. There we go. And hopefully, oh, it looks like I have to stop sharing my demo. Live television, folks, at its best. All right, so get that app. And in fact, you can install it on 2 different devices and start synchronizing immediately without even having to connect up to app services. And then you can get the free tier of Capella, set up an app service, and be able to see the entirety of the capabilities. So when we look at what was happening behind the scenes, here we see very simply, we have Capella in the cloud, and we have Couchbase Lite running in Simple Data Sync, the application on device. And we demonstrated the back and forth peer-to-peer sync, and then of course, cloud to edge sync. And we didn't want to just make it only for fun. We wanted to make sure that you developers out there will be able to take advantage of this really, really cool application and dig under the hood, see how it was actually built and use it as inspiration for your own applications. It's available on GitHub. All right. So now as we start to wrap up, always like to mention customers. We have hundreds of noteworthy customers using Couchbase Mobile. Some are household names, others are small startups, but all of them have specific requirements for high-scale, offline-first mobile applications. I'll just mention a few of them on this slide. PepsiCo. They needed an offline-first sync solution for their order-to-cash mobile application, and it's used by 35,000 sales reps and delivery drivers all over the US and Canada. It's a giant mission-critical application. And the capabilities of embedded database processing and cloud-to-edge sync, they conduct business anywhere without regard for internet. And when they're able, they can sync behind the scenes to the cloud for consistency and a consolidated view of activity across their customer ecosystem. We already talked about Emirates Airlines for their e-tech log, but they also have another application. Their flight staff uses handheld tablet devices with Couchbase Lite embedded in the app that can allow them to service customers while in flight without leveraging internet. They can actually take orders from passengers, and it's synced directly to the galley for meals, for example, that can begin processing. Nothing is ever oversold, and customers get that premium experience that they are expecting. Lodem Games is another. They embed Couchbase in their most popular game called 4 Picks, 1 Word. And they do this to provide 100% uptime for their millions of gamers all over the world. And there's over 800 million downloads of this game and counting. So amazing scale. And it's all managed by Capella App Services. And then finally, Groundhog, who they provide solutions for mining and oil companies. They can guarantee speedy and reliable apps because they actually have that embedded data processing. So thanks to Couchbase Mobile, they can actually operate when thousands and thousands of feet underground without regard for or dependencies on the internet. And these are just some of the customer cases that prove out our ability to support massive deployments of offline first mobile applications. So how can you get started? We wanted to be sure and mention that Capella offers a free tier. I've probably mentioned it a couple of times. But this is a way in which you can actually try things out in a zero-risk environment. Our free tier supports the database as a service as well as app services. You can try out the mobile and edge capabilities at zero cost. In fact, everything that I showed today with Matt in that demonstration can be run from the free tier and integrated there with a simple data sync app. You just get the free tier, set up an app service, download the simple data sync app, connect it to your app service, and you're doing the exact same thing Matt and I did moments ago. And the free tier is also a great simple way to start learning Couchbase. See how the cloud edge data sync can work in your own mobile and IoT apps. So you can sign up. We'll provide that link in resources, or you can just go to couchbase.com and click on Get Started. So Suzanne mentioned that there are upcoming webinars in this series. So we're going to kind of make them continual, if you will. So we've covered pretty much the basics of Couchbase Mobile and synchronization today. But on November 19th, I'll be delving into Couchbase Mobile's vector search capabilities in depth. And this is how we enable AI at the edge. I'll, of course, be showing a demo at that time. And that time we'll be showing vector search-based image recognition, which can be used for a variety of applications. So be sure and join us on November 19th. And then on December 10th, I'll be joined by Wayne Carter. He's the VP of engineering here at Couchbase, but also the developer of these really amazing demonstration applications. Wayne will dive into the code for these apps and show you how Couchbase Mobile powers AI at the edge from a developer's perspective. So be sure to join us for that. You can register using resources. And to wrap up, at Couchbase, we've been doing mobile for over a decade. We aren't going anywhere. If you're affected by MongoDB's recent deprecation of their mobile support, Couchbase is here as a better alternative, providing an end-to-end enterprise-class mobile database platform built to power apps at the edge that are always fast and always on, guaranteed. So, Suzanne, I think we might have 2 minutes for some questions. Questions, I think, can come in private or straight through chat or Q&A. We have a couple in queue that I'll cover, and if we have no more, we can go ahead and wrap up and get everyone back to their day. But Raj asks, how do you handle sync conflicts? So good question. In any distributed architecture application, how can you handle that? Because somebody might try to write something at the exact same time as someone else. So the replication protocol for app services features automatic conflict resolution. It's built in, and it's based on rules, essentially revision trees, where the most active branch wins. And this is better than a clock-based approach, because clocks on different devices in different parts of the world can be different, right? So that's not the best way. Revision trees are the best way. And this resolves conflicting document changes, and it delivers this by applying one of its built-in conflict resolver policies, which can be easily included in your own replication for your applications. And the goal is to return a winning revision based on the configured policy. Unlike other mobile database solutions, however, our conflict resolution rules can be customized. So you can build any conflict resolution that you need to meet your specific requirements. And let's see, let's take a couple more, one more question at least. So Angela asks, how does 5G play a role in improving the performance of apps? And that's actually another good question. I think 5G really requires, it's going to make things dramatically faster, but it really requires edge computing to realize its full potential. The benefits of 5G only apply to the last hop, and that's the edge of your network from the cell tower to your device. But the round trip from that tower back to the cloud can still take over 500 milliseconds or more, depending on where you are. It still requires the internet, right? So You need the ability to run applications within that 5G radius to really take best advantage of the application. And so that's why you need a cloud to edge computing, edge architecture ready type of database. And of course, that's what Couchbase is. And our final question comes from Elizabeth, who is building a hosted app for many customers. How can you make sure no company sees anyone else's data? Well, first, the data is always secure within Couchbase, regardless of where it is. It's encrypted end to end. So it's encrypted while in motion on the wire. It's encrypted while it's at rest. It's also governed by role-based access control. So there's very fine-grained access control rules that you can apply to specify not only who can see what data, but what they can do with that data. But I think really we're also hearing a question that involves a multi-tenancy aspect for the application. And for this, Couchbase Mobile supports scopes and collections and from the cloud to the edge. And what this allows you to do, scopes and collections, is a way in which you can organize your data. So it provides a way in which you can provide multi-tenancy and isolate the data by scope. So customer A would be in scope A, and underlying collections would then be specific to the application, whereas scope B would be for customer B, and so on. So this is a way in which you can isolate that data from the other companies and maintain that multi-tenancy. So with that, I think we're at the top of our program. Looks like we don't have any other questions, any others that do come in. Yeah.
We have one more from Prasanth. He just wanted to know, how are we ensuring security of data that are stored in edge devices?
Sure. So another great, sorry I missed your question, Prasanth. Yes. So the way in which we can actually do this is with our precision within data synchronization. For example, we've got customers that are in healthcare that need to make sure data, when being synchronized across an edge ecosystem, PII, that sensitive data stays within the hospital, for example, in accordance with HIPAA. So this is where our sync channels and our sync filters come into play. So the sync filters, for example, are a way in which you can specify rules that say, this data is okay to synchronize through this gateway, but other data that's sensitive must stay, at the edge, never synchronized off device or never synchronized outside the hospital, for example. So it's a combination of channels and filters, or rules, if you will, of what data can be synced and where it's okay to sync it. So this is a way in which we're able to maintain HIPAA compliance for our medical customers, applications, for example.
Great.
Hopefully that answers your question. Yeah. So with that, thanks everybody. Yeah.
Yeah, we're going to go over that too at our next session, I believe, right? Some more of the security.
Absolutely.
Awesome.
Yeah.
So again,
we'll definitely go a little bit deeper in that, as well as we'll take a deep dive into AI. So some more fun demonstrations coming your way.
Great. Okay, so we hope to see you all at a future session. Thanks so much for joining today. Mark Gamble, thanks, awesome as always. And thanks to Matt for helping us with the demo. We will see you very soon. Take care, everybody.